Hi, in this recording, we will consider the indeterminate form of the type infinity minus infinity. If you have this type of indeterminate form, sometimes you can evaluate by combining the terms and manipulating the result to produce an indeterminate form of the type 0 over 0 or infinity over infinity. This is example 5 in the text. Limit of x goes to 0 plus 1 over x minus 1 over sine x. Notice that when x goes to 0 plus, 1 over x goes to infinity. When x goes to 0 plus, you also know that limit of x goes to 0 plus 1 over sine x also goes to infinity plus infinity. This is why we know that this is the case where you have infinity minus infinity. Let's look at how we solve this problem. We can combine the term as limit of x goes to 0 from the right. The denominator is x times sine x, and numerator will be sine x minus x. By doing so, we have actually converted the indeterminate form infinity minus infinity to the indeterminate form 0 over 0. Let's see how this has become 0 over 0 indeterminate form. You let fx equal to sine x minus x, gx equal to x sine x. Then we know that f and g are continuous at 0 and differentiable at 0. Moreover, f0 equal to sine 0 minus 0, which is 0. g0 equal to 0 times sine 0 is again 0. As I said earlier, f and g are continuous and differentiable at 0. Therefore, you can apply the Hopital's rule and become limit of x goes to 0 from the right, differentiation of sine x minus x over differentiation of x sine x. Now, what is the differentiation of sine x? So we know that differentiation of sine x is cos x. Differentiation of x is 1. How about differentiation of x sine x? In this case, you need a product rule for differentiation, which says that you keep the first term x and differentiation of sine x plus keep the second term sine x and differentiate the first term x here, which will give me x cosine x plus sine x. So the above limit become limit of x goes to 0 from the right, cosine x minus 1 over x cosine x plus sine x. Now, when x approaching 0, this is again an indeterminate form of 0 over 0. Why this is so? Because we already know f prime x equal to cosine x minus 1, g prime x is equal to x cosine x plus sine x. Now both f prime and g prime are continuous and differentiable at 0. In addition, f prime of 0 is equal to cosine 0 minus 1, which is 1 minus 1, you get 0. And g prime of 0 is 0 times cosine 0 plus sine 0 is again 0. Therefore, the above limit is of the type 0 over 0 indeterminate form. We can apply Hopital's rule again. There's a limit of x go to 0 from the right. Differentiation of cosine x minus 1 over differentiation of x cosine x plus sine x. This is the second time we apply Hopital's rule now. Okay, so let's continue the differentiation. This is equal to the limit of x goes to 0. We know differentiation of cosine x is negative sine x. Differentiation of 1 is equal to 0. How about differentiation of x cosine x? And differentiation of sine x, we know. Okay, let's try to do some calculation. Differentiation of x cosine x using product rule, you get x differentiation cosine x plus cosine x differentiation of x, which will give you minus x sine x, since differentiation of cosine x is negative sine x, plus cosine x. That means if I differentiate x cosine x, I have minus x sine x plus cosine x. So I can do that. This is equal to minus x sine x plus cosine x. And then differentiation of sine x, I get cosine x. Let's simplify this. This is the limit of x goes to limit from the right. Minus sine x minus x sine x plus 2 cosine x. Now when x approaching 0, the numerator will go to 0, since we know sine x will go to 0, and the denominator will go to 0 plus 2, since cosine x will go to 1 when x goes to 0, as limit of x goes to 0 plus 2 cosine x is equal to 2, and limit of x goes to 0 plus x sine x is going to 0. So in the end, the ratio is 0. So after apply the Hopital's rule 2 times, we conclude that limits of x go to 0 plus 1 over x minus 1 over sine x. Although this is infinity minus infinity, the result is 0. Let's recap again the original problem. Return the indeterminate form to the case of 0 over 0. And then we apply the Hopital's rule 2 times. And finally, get the answer as 0. That is the end of the recording.